Okay, ladies and gentlemen, we're going to take a look at the Pythagorean Theorem. Now, many of you are going to remember this from grade 9, and some of you aren't going to remember it from grade 9. But either way, it was talked to you. They did talk to you about it in grade 9, and there's some things that we need to know. First of all, we're only going to be talking about right triangles when we talk about the Pythagorean Theorem. No other type of triangle can be considered with the Pythagorean Theorem. And a right triangle is a triangle that has a 90-degree angle. Once you have a 90-degree angle in your triangle, these other two angles have to add up plus the 90 to give 180 degrees for all of the interior angles of a triangle, which means that this angle and this angle both have to be less than 90. So this is the largest angle in this triangle. Now, if you think about angles, and as I increase the angle, look at the distance between these two fingers. As I increase my angle, that distance is increasing. So what happens is, this turns out to be, because this is the largest angle compared to this one and this one, this ends up being the longest side. So the longest side is always, 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 always opposite the 90-degree angle. And that's a big deal. That's a really big deal. And that's such a big deal that we have a special name for this side. And it's called the hypotenuse. Hypotenuse. You should probably learn how to spell it, but you'll get away with just HYP for the most part. So the hypotenuse, that's that side. Now these other two sides go by many other names. Sometimes we call one A and one B. Sometimes we call one side 1 and the other one side 2. It doesn't matter which one's which, if this one's side 2 or this one's side 1. Sometimes we call them, if we name the triangle, we could call this side little a, this could be side BC. It doesn't matter, it doesn't matter, it doesn't matter. What matters is that the angle opposite the 90 degrees, that the side opposite the 90-degree angle is called the hypotenuse. In fact, for the most part, these two sides are generally referred to as the legs of the triangle. So there's the hypotenuse and what we call the legs of the triangle. Okay, so Pythagorean Theorem. Now, what did Pythagorean Theorem really find out? Pythagoras and his following, that's a neat story. We'll talk about that one day, but not today. But Pythagoras had a whole bunch of people that followed him. They lived on their own little island, and they believed that math was a religion, to be honest with you. And yeah, they took math really far, even farther than I take it. So what they did was they determined that if they had these sides, this side, and this side, all of different lengths, that if you took any right triangle and if you calculated the area off of each side, so if you took this side length and this side length, and so whatever that length was, you came out this far, you went up the same amount, and you went back this amount, that this area, and I'm going to let's just call this little a for now, so that'll be little a, so area here will be a squared, length times width. And then this one will come down like this. Okay, so come out this length, come down this length, the same amount. We'll call this B. This will be B. That'll be B squared. And I drew this a little bit too long, and that's okay. I can get rid of that. All right. And what Pythagoras really, really, really found out was that this squared in here, the area of this square, it doesn't look like a square. It should be more squarish. That should come down more. And the area of this square could fit perfectly into the area of the square coming off the hypotenuse. That these two would fit perfectly into this area here, into the hypotenuse squared. And sometimes we call it C, in which case this is C squared. So he figured out that the area off of this side plus the area off of this side would fit perfectly into the area in there. And I'm going to post a video in the LMS that's going to show this a little bit better. It's a little demonstration using water, and that I find really, really neat. So you'll take a look at that, and that's kind of cool. And anyway, this is what we generally end up using. Now, the problem with this is that we forget what A, B, and C are. C has to be the hypotenuse. It would be very, very foolish of us to say that this area plus this area could fit in that tiny little area. That would be foolish. And it would be foolish to say that this area plus this area could fit in this area. The only way it works is if the two smaller areas fit into the larger area, which means that this always, always, always has to be the larger area, which means this always, always, always must be the hypotenuse. And if you goof that up, everything else is wrong. Okay, I'm going to stop the video there and we'll come right back.